Hi, welcome back to the second part of the explanations. And another homework that I assign you is the forces practice. There are one, two, three questions only. Okay, some of you are asking me questions how to do this. Okay, so I'll do the quick explanations on how to answer these questions. All right. Okay, so let us review the first questions. So they ask you, an astronaut has a mass of 65 kilogram on Earth, where the gravitational field strength is 10 Newton per kilogram. So you have to calculate the astronaut's weight on Earth, okay? So you know already the mass is 65 kilogram. So mass is 65 kilogram. So they give you the gravitational field strength is 10. So this is G is equals to 10. And they ask you to find weight. So how to find this? Okay, let us review. Okay, weight is equals to mass times gravity. Okay, so weight equals to mass times gravity. So weight, or you can write down as in the short form. So the mass is 65, your gravitational is 10, so you get 650 Newton. So the unit for the weight is Newton. Okay, so now let us continue to the second part, question number one. So they ask you, okay, complete the following sentence. So the astronaut's weight on Earth is, so where do you get the weight? It's actually from the gravitational force, okay? So Earth is from the gravitational or any attractive force between the astronauts and Earth. Okay. So you get weight from the gravitational force. Okay, for C, the astronaut undertakes the moon landing. On the moon, the gravitational field strength is 1.6. So you can see the 1.6 is actually the value of G. Okay, so if they ask you what is the astronaut's mass on the moon, so you have to figure out, okay, so first of all, okay, mass is the thing that is not changing. So the mass stays 65 kilogram. So please remember this, we have mass and weight. Okay, the differences between these two is that, okay, first of all, of course, the unit is also different. Mass we measure in kilogram, weight we measure in Newton. So mass is actually the quantity of matter in an object. Okay, so quantity of matter in an object. All right, weight is the force of gravity on the object. So we can see from these two differences, okay, mass is only the quantity of matter. It means that it included your blood system, your organs and everything. So that is why mass will stay the same. So everywhere you go, if you go to the moon, the Jupiter or other planets, or you go to anywhere other than Earth, your mass will still the same. You are you. You are not going to shrink down or pop up. Okay. So however, the weight, it will depends on the gravity gravity of places, so or planet. So it means it depends. So if you go to the moon, your weight might be lesser. If you go to Jupiter, it might be greater or less. It depends on the gravity of the planet. So mass everywhere, if you go, it always stay the same. Okay. All right. So there are the two important points for the mass and weight. Okay, let us move on. Okay, this one, calculate the magnitude and the resultant force on the car. So you see 12,000 Newton to the front, 500 Newton to the back. So you just minus both. So you get 1,500 Newton. Okay, because it is 2,000 minus 500. Right. So next one, tick the box below that describes the motion of the car. So you can see that, okay, since the car, the forward force is greater. So the backward force is only 500. This one 2,000. So it means that it will move forward with 1,500 Newton. So the answer must be the second box. It cannot constant speed because the forces are different. So it's greater to the front. It cannot be the third one also. It cannot backward constant, backward and backward cannot. The only answer can be is the second one. It travels forward with increasing speed because the forces are unbalanced. It means that greater forces to the front, greater forces from the thrust, so it will speed up. Okay, next, the frictional forces increase to 2,000 Newton when the car is moving. So what happens to the car? So let's say your frictional forces increase to 2,000 Newton. Okay, many of you answered they will stop. Okay, if the object in motion, remember the Newton's law of motion, the first motion said that um, all object will try to retain their current motion. So object in motion will stay in motion. Object at rest will stay at rest except there is an external force. But in this case, there is no external force stopping them. It's just that the forces become balanced. So it means that if your car is moving, okay, so even though this is 2,000 Newton and up here it is increasing to 2,000 Newton, if your car is moving, it will continue moving. Your car will not stop suddenly because there are nothing at the front except if there is a wall, then only your car will stop. If there is no wall, then your car will continue moving. Okay, so in this case, what happens to the car? It will move at constant speed. So it means that if you are driving the car, if you didn't press the fuel pedal, I think this the accelerator on your car, if you just maintain the push on it, so your car will move at constant speed. Okay. So suggest two things that might have caused the frictional forces to increase. Okay, these external forces, frictional forces, you cannot change anything on the car. You just have to explain what might happen. So some of your answers when there are more passengers. Okay, more passengers, it's not logic because the car is already moving. So you cannot add on the passengers in the middle of journey, right? So that is why I said when you want to answer, it must be related with the question. Means you have to imagine you are in the current situations. So if you see here, two things that might have caused the frictional forces increases, anything related with the car. It means that anything happens to the car, not the people inside the car. So this question, we are focusing on the car. So please, this one focus on car. All right, so it can be increased air resistance. It means that if you are, because here also again, they just ask frictional force increases. They don't ask whether the car will slow down or move faster. They don't focus on that. So frictional forces is also included. Okay, frictional force included the air resistance. Okay, resistance from the tire as well. So it's included air and the resistant tire or the ground. So both also acceptable. There is also frictional, because frictional is actually any force that is a opposite motion. So that is the definition for frictional force. Okay, so they ask you what is happening. So you can say increase in air resistance. It doesn't matter if the car, because if you want the air resistance to be increases, the car must move faster. So it doesn't matter about the speed. We are just focusing on the air resistance. Okay, and you can also say flat tire. Okay, this is also related, or you can also say brakes applied or any other example. So if you give other examples like increase the road resistance, the road is have the extra pavement, new old road which is has more resistance, something like you have to mention about the things that affected the car motions, then it is acceptable. Okay, all right, so let us look at the number 3A. Okay, actually 3A and 3B, I'm so sorry. Actually, I should discard this question because you guys haven't learned about moment. However, I will share with you the answers in the soft copy. Okay. I don't want you guys to confuse yet. This one we are going to cover after this. Okay. But for those who are submitted already, I will mark your answers. The rest, I will share your answer later. Okay. So don't worry about this question. However, it is actually about the stability only. As long as you explain about stability, acceptable lah. But actually, there are more than that. We have one topic for this. Okay. So this is not included yet in your topic. All right. We move on to 3C. Okay. They ask you the same question. Okay. They ask you, a bus is traveling along a straight road. So the bus and the driver have a combined mass of 16,000 kilogram when there are no passengers in it. So the bus has 73 passengers. The average mass of each passenger is 65 kilogram. So what is the total mass of the bus, the driver, and the 73 passengers? Okay, very direct as well. So you know already the mass of the bus. Okay, mass of the bus is equals to 16,000 kilogram. And then so this is the mass of the bus plus mass of the driver, because when there are no passengers, they have the combined mass of 16,000 kilogram. And then we also know that the mass of the passenger is equals to 73 times 65. So 73 times 65 is equals to 4745 kilogram. So what are the combination mass? So mass total is equals to 16,000 plus 4745. So the overall you are going to get is 20,745. Okay, but like I said last time, you can round up to the answers to the 2 to 3 significant figure. So if you answer 21,000, oops, extra zero, 21,000 kilogram is also acceptable. Okay. So actually the answer, like I said last time, you can leave it in this form, but we encourage you. Actually, we want to practice with you guys to answer in 2 or 3 significant figure. Okay, but most of the time we answer in 2 significant figure. But if don't delete your previous answers like this one, just leave this answer here and just your final answer, you write 21,000. Who knows, some of you might accidentally write down, when you round up, you make a mistake. So we can still look at your previous answers. Okay. All right. Number 2, The fully loaded bus accelerates uniformly from rest to the speed of 14 meters per second. The time taken to reach speed is 20 seconds. So what are the resultant force on the bus during the acceleration? So first, when you see there is a speed and then there is a time taken is 20 seconds, you need to know this formula you have to write down. So resultant force is always F equals to M times A. Okay, so you know already that the mass of the bus, okay, the resultant force during the acceleration with the fully loaded bus, it means that mass total. Okay, so let us see. Okay, acceleration in here. So what is acceleration formula? Okay, let us recap. Acceleration is the change in speed over time taken. So acceleration in this question is the change in speed uniformly from rest to the speed. It means that, okay, if we write down here, F is equals to M times acceleration is also equals to V minus U over T. Okay, right? So it means that that's why I said physics, it's always related the equations. Okay, so in this case, you know that mass is 21,000 because it is a fully loaded bus times your final speed is 14. This is your V. Your initial speed is rest. It means it is 0. So U is 0, final is 14. So 14 minus 0 divided by time, which is 20 seconds. So when you get this, you substitute. So 21,000 times 14 divided by 20. So 21,000 times 14 divided by 20, you get 14,700 Newton. So like I said, when you want to put the answer, you can round up to two significant figure. So you can round up to 15,000 Newton. So that is the answer for this. Okay. So please remember, like F equals to MA, there are various ways you can find the value of M. So let's say if the question didn't give you M, mass, but they give you weight, then you can find your mass. Or they give you the density and volume, then you still can find your mass. So please always relate the equations. And acceleration is the final minus initial. Okay, so or change in speed lah. So that is why you can always find it from the questions. This is not a very direct questions. Okay. All right. So next one. Okay, number 4. Okay. What is the free fall parachute jumps out of aeroplane but doesn't open his parachute until after sometimes have elapsed. So this first part is when he jumped. So his speed is increasing. After at one point, the speed stay constant. Okay. So after that, here, so this is the diver. Okay, he is falling down. Oops, I should draw the head down. So he is falling down, but the speed is increasing. Okay, and then here, when he is falling down, but he's stable already, okay, he opened the parachute. Okay, so that is why the speed is dropping, and after sometimes it will be balanced again. Okay. All right, so let us have a look at the first one. What is the value of acceleration immediately? So it means immediately after he has jumped. So it is due to the gravity. So it is 10 meter per second squared. Okay, immediately, only that once. But then he is increasing lah towards the gravity. Okay, how can you tell that the acceleration decreases until point A on the graph is reached? So again, this is a speed time graph. Acceleration is from the gradient. So you can just say gradient decreased or slope decrease, or you can also it become less steep. Okay, all right. State why the acceleration of the parachutist decreases until point A. So why? So now they ask you why. Okay, so like I said, when they are falling down, at first when he is falling down, the weight is greater. Okay, the trick is here, your weight will not change. Actually, when once you fall down, your weight is greater. Why? Because at that point, the air resistance is smaller. But as you going down, at one point, your weight and air resistance is balanced. Okay. So why the acceleration of parachute decreases until point A of the graph? It because air resistance increasing. So the tricks are for the terminal velocity, it's always the air resistance is the one that change. The weight will stay the same actually. Yeah? It's just that at the beginning, they are greater because air resistance is smaller value. So air resistance increasing as speed increasing. Okay. My handwriting. So you get 2 points. So how do you get 2 points? 1 point is this one. 1 point is this one. So you have to mention why air resistance is increasing, because speed also increasing. So the faster you move, the greater the air resistance affect you. Okay. So next one, we have consider section AB of the graph. What is happening to the parachutist speed in this section? So you can see that AB of the graph. So what happened to the speed? So like I said, this is still a speed time graph. So you can see, you can say that the speed is constant. Or you can say stay the same. So it means that the speed stay the same. All right. Number 2, what can be said about the forces? So the forces on the parachutist during this section. Okay, like I said, when at one point, why you get the constant speed? Because the forces are balanced. So when forces are balanced, we say that there are no resultant force. Okay, no resultant force. It means that there are no value of resultant force. Resultant force is the total force acted on the object. Okay, or you can say that weight equals to air resistance. Also correct. Okay, or you can also say force up equals to forces down. So like that only, then you get 1 mark. Okay, so for E, at which point did the parachutist open his parachute? So he opened his parachute at point B, because immediately when he opened, he will go down. Okay, so it is B. Why the speed decreases from B to C? Okay, so why? When he opened the parachute, of course, the air resistance will be greater than his weight. But as he's falling down, bit by bit, they become stable. It means that weight balance with the air resistance. Okay, so why? Okay, you have to explain because there are 2 marks. So first of all, you can say larger air resistance. Okay, or you can say resistance, sorry, air resistance is bigger than weight. So air resistance bigger than weight. Okay, so this is 1 mark. Okay, if you answer larger air resistance or air resistance bigger than the weight, this 2 is 1 mark. Okay, how to get the second marks? Okay, the second marks, you must explain why there are greater air resistance. So why? So it is because of the larger area. Or you can say due to the parachute. If you didn't mention also, as long as you say there are larger area, thus the air resistance bigger than the weight. So this is another 1 mark. So because it is explanations, you have to mention why they have the larger air resistance. Okay, so that's all for this. Hopefully it will help you to understand this topic. Okay, so that's all. Bye. Thank you for listening.